Hi everyone, my name's Professor Michael Gradisar from Flinders University. I work in psychology. I'm also a clinical psychologist and I specialise in sleep, and I'm going to talk to you today about adolescent sleep and technology use. So first up, I always ask this question: what do these people have in common? And if you don't know who they are, we've got David Bowie, Tupac, Ozzy Osbourne from Black Sabbath, and probably one of the most famous teenagers in recent memory. And if you don't know what the answer is, it's changes. So basically, David Bowie, Tupac, and Ozzy Osbourne sang about changes, and the teenager is going through them. So a couple of years ago, we wrote about this, particularly about the physical changes that you can see with teenagers, how they go through changes in their height and shape. But that's something that you can see quite clearly. However, what we can't see are the changes that happen due to their sleep. And this is because of biological changes that are occurring within the body, and I'm going to speak about that today. But just to give you an example, here on the left is myself with my two teenage boys, and the one on the left, this is in 2016, as you can see I'm taller than him. And then 3 years later, when we're hiking through Canada, you can see how much he's changed in 3 years. And as I've seen these changes in his height, I've also seen changes in his sleep. So what we have here is what we call a model or a description of adolescent sleep. So at the top with that black bar that says sleep, this basically says that teenagers are able to get a decent amount of sleep. In fact, it's about 9¼ hours. However, we have all of these different influences that can actually restrict an adolescent's sleep. And what we see down the bottom is that the sleep is less. And this is what happens when we're in our actual environment, going about our weekdays. And so what we have here on the left in red are the biological changes that occur in sleep. First, we have sleep pressure, and that's simply put as the amount of times that we're awake. The more we're awake, the more sleep pressure we build up and the more sleepy we feel. But for teenagers, this means that this process doesn't work so well, which means it takes a bit longer for us to feel sleepier. The other one is a circadian phase delay. This basically means that the body clock starts to delay, meaning that the body clock is telling teenagers to go to bed and fall asleep later and also wake up later. And so these are two very powerful biological influences on sleep, which means that teenagers essentially are very awake at night for these two reasons. But what we're going to focus on today are some of these psychosocial pressures, and in particular a couple of those down the bottom, such as screen time and social networking, because this has been a very popular topic and a lot of people believe that technology is the big bad boy and affects teenagers' sleep. So what I'm going to take you through today is some of the studies that we've performed in our sleep laboratory at Flinders University. And this one here was looking at the question of whether the bright light from screens affects our sleep, because a lot of people believe this to be true. Yet going back at least a decade ago, we found that there was actually no science really supporting this. So we set about trying to design a study to test it. So what we did is that we looked at the typical hour before bedtime, and we gave teenagers on one night a bright iPad screen, as you can see on the left there. And on another night, we gave them the same iPad, but we used what was called f.lux. Some of you may have heard of this, but it's very similar to what you see on an Apple screen as well, where you get more of an orangey glow coming from this screen, as you can see there on the right. And down the bottom, we've got what's called a spectral analysis, looking at the different colors of light. You can see on the left there with the bright iPad screen that you get a lot of blue light coming from the screen. And blue light is very alerting, hence why a lot of people believe that the light coming from screens can be very alerting and means that we have problems with our sleep. And as you can see on the right, what happens is that if you have something like f.lux or night shift mode on Apple, is that the blue goes straight down. Therefore, the idea being if you've got less blue light coming from the screen, then you'll be able to fall asleep better. So what we did is we tested a bunch of teenagers in our sleep lab, and what we tested them on was things like information processing speed and their accuracy as well. And this was in the lead up to bedtime whilst they were using the iPad. We also measured how long it took them to fall asleep, and we did this by placing electrodes on their scalp and measuring their brain waves and detecting when they fell asleep. As you can see there, there's a red cross, meaning that we didn't actually find that using a bright iPad in the hour before bed did anything to their sleep compared to having a dim screen or by having the f-dot lux. And although we found significant effects for information processing speed and accuracy, you had something like 23 millisecond difference between the two different conditions. And something like that is very fast, but it doesn't necessarily mean much. And a lot of teenagers aren't necessarily doing exams in the evening. So we actually don't place too much importance on this study. And in fact, what's happened since is that there have been several other studies that have tried to do the same sort of thing. And surprisingly, they've also found that the blue light from screens doesn't necessarily directly affect sleep. So that's really the take-home message here, and surprising that this is really counter to a lot of the different information that's out there on the interweb. So if it's not the bright screens, what else could it be? Well, it could be that it's quite alerting to use technology at night. So it might be that we're quite stimulated and what we call mentally and physiologically aroused. So what we've got here is a list of different studies. Working from the top left, we've got one in Japan by Higuchi et al. And they had young adults, and they had two different conditions. One was playing a video game late at night, just before bed, and the other one was doing a mental arithmetic. And they found that there was a significant difference, in statistically speaking, between the two groups, but the difference was 2.3 minutes, which wasn't much. The next study that was performed by Iverson in 2009, they also had two different conditions. One was teenagers playing an animated game, and the other one was playing an R-rated violent video game, which actually was banned in some countries. They measured sleep subjectively and found that the difference between the two groups, the one playing the animated game versus the violent video game, was 12 minutes. And again, that's not too much difference if it takes just 12 minutes longer to fall asleep playing a violent video game there. And then in 2010, Weaver et al., so that was our group here at Flinders University, we wanted to look at the difference between two different types of, not necessarily games, but maybe activities. So if you can see down on the bottom right there, one group, or I should say on one night, the teenagers came into the sleep lab and they played Call of Duty 4 for an hour before bed, in bed, and on the other night they watched March of the Penguins, which is a documentary about penguins. In fact, that's the most exciting part of the movie there, which is those penguins running around. We actually had 1/3 of the teenagers fall asleep while they were watching March of the Penguins, but regardless, they still managed to fall asleep after the hour of watching the documentary. As you can see there, the difference in the time taken to fall asleep was only 4.5 minutes, and we measured them again by having electrodes on their scalp. And then after that, we thought, okay, well, let's have a look at the amount of time that people can actually play violent video games. So in 2013, again, we got some teenagers into the sleep lab, and we got them to play a new violent video game, as you can see here, with all of that blood splattering around. So we gave them on one night 50 minutes to play this new game, and then we gave them an increased dose, so 150 minutes on another night. And what we found, if you can look at the lower left panel there, in terms of falling asleep with the O means objective, and that means with the EEG, 3.5 minutes difference in the time taken to fall asleep. Again, not much difference at all. Subjectively, the reports were different by 17 minutes, which shows you the difference between measurement of sleep. And then finally, Iverson, again, the Swedish group in 2013, they did another study looking at animated video games versus violent video games, repeating the same sort of study, and also found 18 minutes subjective difference between falling asleep in the two different conditions. But what they found was something new and interesting, which is that they found that there were some teenagers that took a lot longer to fall asleep, and there were other teenagers that didn't get affected by playing violent video games. And this has actually led to some new research that we've conducted as well. So just to summarize the two studies above, so Weaver et al., that was us in 2010 with the Call of Duty game, found a mild difference between the time taken to fall asleep. It wasn't much to write home about. And then we had Daniel King's study with the increased dose and the amount of video gaming. Again, there wasn't much difference in the time taken to fall asleep. So in 2015, what we did is we started to look at some of the characteristics of teenagers, because we have this concept called individual differences, meaning that some people can have more of something than other people. And in this case, what we did is we got teenagers to fill out a whole bunch of different questionnaires, and then we got them in the sleep lab, gave them a new video game. In this case, it was BioShock, and we allowed them to play at 8 p.m. on a school night. And we said, you can play this game for as long as you want, but we're going to be waking you up the next morning at 7 o'clock in the morning and taking you to school. And what we found is that there were differences in when the teenagers would actually turn off the game and stop playing. And the ones that turned off the game later, those were the ones that we found differences on our risk-taking scale, specifically the consequences of taking risks. So in other words, those teenagers that didn't care so much about the consequences of taking risks were the ones who were more likely to stop playing the video game later at night. And then another study we did in 2017 was to look at a different sort of concept called flow. Now, flow is something where you basically lose sense of your surroundings, you get really into the zone, you're really immersed into what you're doing. And it doesn't necessarily have to be with video games, it can be with reading. Some people who are older than you guys even find knitting that they can get in the flow for that. But definitely video games is something that people can experience. And again, we found in this particular study that we gave the teenagers Tomb Raider, and again we said at 8 o'clock you can play this game for as long as you want, but we're going to wake you up in the morning at 7 o'clock. So in other words, you can't play too long. We found that the teenagers that stopped playing later at night were the ones that were more likely to get into this flow state, meaning that they were immersing themselves more into the video game and more so losing track of time compared to other teenagers. So the point of this is really at this point to show that technology use doesn't blanketly affect teenagers' sleep. And it's not necessarily the type of game here that we're sort of seeing different effects for. What we're seeing most likely is that there's characteristics of the teenagers that are more likely to affect their sleep. So some are more vulnerable than others. And so if we step back a bit and get out of the sleep lab at Flinders, we can also do other types of studies. And this one was done by Kate Bartell, who did her PhD, looking at all the different types of factors that can influence a teenager's sleep. So what this means is that she was able to look at the science and the studies that have already been performed and what variables were correlated with a teenager's sleep. And then what she was able to do is what's called a meta-analysis. And a meta-analysis is basically to collect the data from all of these different studies from all around the world, put them into one single database and analyze them. So it ends up that she had data for over 85,000 teenagers from across the world from all of these different studies. And this is summarized on the next slide. And what we see here is it's a bit like what we call a pie chart if you haven't seen these before. And we've got the different color coding for all the different factors that can affect a teenager's sleep. And as you can see there, for technology use is that top thin blue piece. And as you can see, that doesn't really affect teenagers' sleep, or it doesn't contribute as much to a teenager's sleep as what a lot of people believe. And so this equated to less than 2% of the contribution towards a teenager's sleep. However, if you look at the next piece of the pie, which is pink, that's parent set bedtimes. That has much more of an influence in a good way for a teenager's sleep. And furthermore, you can see other ones that are further down the track, the purple piece and the light blue piece. This is tobacco and alcohol. You put those together, these two particular substances, and they affect a teenager's sleep far more than technology use does. So it really does go to show when you apply the science is actually telling a different story to what you hear on the internet or even in the popular media press, which is a bit of a disturbing and a bit of a disappointing issue that the science that's being conducted isn't actually getting translated to the people that need to know about it. But as you can see with this piece of pie, obviously there's one big factor that is contributing to teenager sleep. We believe again that it seems to be the biological factors, because in the study that Kate conducted, a lot of these were surveys, and for these surveys you can't measure their biology. So in other words, what is left over from looking at all of these different influences, all these different little pieces of the pie, is this big biological contribution. And in some ways, we might also get what's called error measurement. So you saw with some of those video game studies that depending upon whether you measure sleep with electrodes or by asking self-reports, you can get slight differences as well. But we believe the major contribution here is biology. So going back to this model, we can see that it isn't necessarily screen time or social networking that has a big influence on restricting teenagers' sleep, but it's more likely going to be the biology. But on the end of sleep, when people are waking up, there can be another contributor, which is called school start time. This is particularly so for teenagers in the US because they have to start school in some districts at 7:30 a.m. And sometimes they've done studies where they're called starting school time later studies. So they changed the school starting time in the US from 7:30 to 8:30. In other words, they become more Australian. And that's when they find that there's actually improvements in the teenagers' sleep and also in their behaviour, their emotion regulation and their grades. But we don't have much of an issue here in Australia because we're already starting on average at 8:30 when it comes to starting school. But nevertheless, we've also done some studies in schools and using a different approach instead of delaying school start times. So specifically, over a decade ago, we started going into schools and providing some sleep education to high schools and to teenagers. And so these programs were initially 4 classes that were focused on sleep and sometimes other factors. And what's happened is that we found, at least in the first 2 trials, that we were able to increase teenagers' sleep knowledge, but not necessarily change their sleep. So it wasn't really until the 3rd trial that we found that we got it right. And so not only did we find that we were able to increase the sleep knowledge of teenagers, but compared to teenagers that were just doing their classes as usual, so they were the controls, that we were able to increase the amount of sleep for teenagers through the sleep education program by about 22 minutes each night. So 22 minutes doesn't sound like much, but if you times that by 5 school nights a week, that actually does amount to something significant. And I guess the good news about this is that we found that we needed to add elements in order for it to be effective. So, for instance, when we're trying to improve teenagers' sleep and trying to correct their body clock, one thing that the body clock responds quite well to is bright light. So we were able in this study to provide bright light glasses to teenagers, and these were invented at Flinders. The point of them being that they provide light when the sun isn't available in the morning, such as when we're getting winter times and the sun isn't really coming up over the hills in Adelaide early enough. The other aspect to it was that we started to include parents, and when we included parents, the parents were able to support the teenagers. They weren't necessarily needing to do too much, but just be a bit more understanding of their situation and how tough it is for them to fall asleep at night and how tough it is for them to wake up in the morning as well. And starting to understand that it might not necessarily be the technology use that's causing the sleep problems, but more so their biology. And so that's one method of trying to get to teenagers, and a lot of teenagers, is to do some sleep education in schools. Another thing that we formed is the Child and Adolescent Sleep Clinic at Flinders University. And we've had this running for the last 15 years, and this is really for teenagers who don't necessarily want to get some general sleep education, but actually want to get some more tailored information and specific sleep techniques that are going to help their particular issue. And so this clinic is still available. If you find that you need to get some help, especially as you're getting through the teenage years into grades 11 and 12, by all means, have a conversation with your parents and see if you can contact us. If you can't write down these contact details here, just Google Child and Adolescent Sleep Clinic at Flinders University and you'll be able to find us. So at this point, we often get asked a number of different questions from teenagers and from teachers. And so I've just got a couple of frequently asked questions here. And the most common one we get from students is this: does this mean I can tell my parents I can use my phone in bed for longer because a university professor said so, and he knows more than most people about this particular issue? Well, it does seem to be that way, but my answer would be that you can pass on the facts that you've learned from today. And it's really important when we're talking about science and translating the science that we don't use Chinese whispers, that we try to keep it as accurate as possible and we try to repeat the facts. But another thing I might encourage you guys to do is maybe become like a psychologist, maybe become like a scientist. You can actually do your own experiments and you can learn some new information when you do these experiments. So for example, you might have a conversation with your parents and you might sort of say, how about we try an experiment where I can actually use a particular device for an hour longer each night, and we can do that for 2 weeks, and then we can see if that actually does affect my sleep or not. But in doing an experiment, you can also do the reverse. And we've done this as a particular study. We've actually got teenagers to record what it was their usual time that they stopped using their mobile phone at night. And then what we did is the following week, we asked them to stop using their mobile phone 1 hour earlier than usual. They could go to some sort of other device, so it didn't mean stopping technology use completely, just not using their phone. And what we found is that when they were able to stop using their mobile phone 1 hour earlier, that they were getting roughly 20 minutes of more sleep per night. So again, something that was very similar to our sleep education program that we did. Admittedly, a lot of teenagers didn't like to give up their phone, so it's not for everybody, but it's an example of where you can try to experiment in both directions. Try to see if you can have a bit more technology use, see if that does affect your sleep, and try it for a couple of weeks. But also try to do the opposite. What happens if you just stop one device for an hour earlier for a couple of weeks? Does that actually improve your sleep? And so teachers, they usually get a bit worried when we start to do a talk like this and we start to tell people about the facts of technology use, and it's not all bad. But there's often this question that comes up from teenagers, what about the gamers? We have many students who are probably gaming well into the night. Well, that is definitely true. That definitely happens. And even at our sleep clinic, we find that we have teenagers that actually cannot get to school and they're gaming all night. And because of this, it's obviously a problem, and they want to have their sleep changed so that they can actually fall asleep earlier, have a bit of gaming, but still also go to school. So our answer to this is that our sleep lab studies that I've described to you today, they tested gamers. You can imagine when we sort of put out a call for teenagers to come and get fed pizza, play video games, fall asleep and get a voucher, that a lot of people came and they were gamers that were interested. So I guess one answer is that these particular teenagers or students that teachers have in their class, they might be high on this flow characteristic and or risk-taking. And so they are probably more at risk of doing it, but it doesn't necessarily mean that everyone is at risk. And hopefully that message has got across in this talk today. And just to sort of inform you guys where we're going with this is that the information I presented, especially with the meta-analysis, was looking at a huge amount of teenagers. So that was over 80,000 teenagers. And you can see there, when you look at all teenagers, that there isn't much of an effect of technology on sleep. But that's not denying that there can be some teenagers that are quite vulnerable, but they are the minority. But we're actually now looking at the extreme end of gaming and actually looking at the sleep of esports players. If you don't know what esports players are, they're essentially professional video gamers. And so we've done some studies and we've collected some data, and we're looking at trying to publish these as well. This is an example here of a professional South Korean team called Gen G, who we've been doing some work with. And so these guys actually get paid to play video games professionally and compete. And we've also looked at Australian groups as well who don't necessarily make money from their professional video gaming, so they actually have regular jobs and they try to sort of practice after work, etc., and compete in a more casual sort of way. And certainly, I guess what we've found is that their sleep of these professional video gamers is that their sleep is certainly quite poor. It is falling asleep very late and waking up very late. And so what it does mean is very tailored, intensive intervention to try to correct their sleep, because for some of them, they're really only getting a few hours of sleep. And it gets to a point where their sleep gets out of control, and that can actually affect their performance. And if it affects their performance, then their team might be more likely to lose. And these esports players are also on short contracts, so they have to perform quite well. So I guess stay tuned for those results. But if you're thinking it would be a fantastic thing to just play video games a lot and compete professionally, just to let you know that the probabilities of playing professionally as an esports player, the odds of that are getting close to being the same odds of winning Wimbledon tennis. Admittedly, there is a counter argument to that, which is that the teenagers that won the Fortnite competition last year actually earned more prize money than Djokovic did at Wimbledon. But may I probably propose to you guys that what you might want to consider is that the odds are a lot better if you're able to, say, study at Flinders University, study psychology, and learn what you can about being not only a scientist, but potentially a clinical psychologist as well. So instead of necessarily being an esports player, you could actually work alongside these guys and see if you can help them try to perform a lot better. With that, I'd like to acknowledge my own team. I can't do all of this work by myself, so I've got a great set of people that can do a lot of these studies, and so we can learn more, and hopefully we've passed on some good messages to you guys today. Thanks for your attention.